Calculate the heat and work transfers, cycle efficiency, work ratio, and SSC for a Carnot cycle. Okay, before that, I should give you the formula for SSC. Okay, I should give you the formula for SSC and likewise that of the network too and the work ratio. So other parameters are work ratio, which is given by RW, that's net work output all over gross work, which is the turbine work, gross work. Okay, the next is the specific steam consumption. It is the SSC that we read in that question, given by 3600 over network, and it's in kilogram per kilowatt hour. Okay, in kilogram per kilowatt hour. So we are going to be solving or seeing this kind of parameters in the question that will enable us to solve it without any problem. So over to the question. So firstly, what you do is to draw your TS diagram. Draw your TS diagram. That is the first thing to do. Anytime, what, any day. So the TS diagram would be like this. The TS diagram would be like this. TS diagram would be this way. Okay. TS diagram. Sorry about that. Need to get a perfect line for this. So this should be on this, so that you'll be able to get exactly what we're drawing. Okay. Now I'll clean off this other edge. Right, so okay, this is TS diagram. Okay, it's this way. So we have what? Yes, 1, 2, 3, and 4. Okay, they said the pressures are 30 bar and what, 0.04 bar. Okay, now you pick your steam table. So recall that I said here is the saturated vapor line, and also I said that here is the saturated liquid line. So this is denoted by subscript F. So saturated liquid is denoted by subscript script f. So for example, whenever you see HF, UF, SF, they are under this what category. So it's on this line, means this part of the line, the tip of this is on this line, so it's on the liquid, saturated liquid line. So the same thing happens for the saturated vapor. Saturated vapor has subscript G. So just like UG, VG, HG. So for this question now, pick your steam table. You go to 30 bar. Okay. So from the saturated vapor table at 30 bar, we have that is at P1 equal to 30 bar. Of course, P1 is equal to P2, constant temperature. Also, since the pressure is, since the temperature is the same, pressure is also the same. So at P1 equal 30 bar. So find your HF. Okay, HF is equal to H1, which is equal to what? 1108 kilojoule per kilogram. Also find your SF. Remember here that S1 is equal to S4 and also S2 is equal to S3. Okay, so at P30 bar, find your SF2, which is S1. Okay, that is equal to 2.645 kilojoules per kilogram Kelvin. Now H2 still at 30 bar, of course, 30 bar, which is P2. Look at it, it doesn't change, it's the same pressure at state 2. So go to the HG part, the vapor part, and find HG. That's your H2. What's the value? 2803 kilojoules per kilogram. Then find the SG, which is S2, and that is 6.186 kilojoule per kilogram Kelvin. So remember, but from the diagram, S2 equal to S3. Okay, so having said this, you find what S3 is equal to what? SF3 plus X3, SFG3. Okay, so at P3, if you look up, you see that at 3 the pressure is 0.04 bar. So at P3, which is equal to P4, which is 0.04 bar, you go there and pick the value of SF and SFG. So but you know that S2 is equal to S3. I know the value, I found it. So this will give us 0.472 plus X3 into 8.051. So subtracting and dividing, we have that 6.186 minus 0.472 all over 8.051. X3 will now be what? 0.761. That is the what? Dryness fraction. And why did we find the dryness fraction? If you check, just like I said before, I said anything within this region, anything inside here is the wet region. Like anything inside this region is wet. So if it's outside here, it's still a liquid. So when it's outside here, it's superheated, it's in a vapor state. So but in between here is partially a vapor and partially a liquid. So it's still wet, it's not totally dry. So it will be totally dry when it's here. Okay, so this is the wet region. Alright, so with the x3, we can find our h3. So h3 is given by hf3 plus s3 hfg3. So h3 will be still the same at 0.04 bar. You find your hf3, which is 121 plus 0.716 into 2433. So h3 will now be 1863 kilojoules per kilogram. Alright, so we are done with state 3. So for state 4, remember that S1 is equal to S4 too. So but what is the value of S1? We got it to be 2.645 kilojoule per kilogram Kelvin. So you can say that S4 is equal to SF4 plus X4 SFG4. So SF4 and SG4 at 0.04 bar. Okay, at 0.04 bar, we have that S4, which is okay, we know the value of S4, so we can just say straight that 2.645 is equal to whatever value of S4 you get there, which is 0.472 plus X4 into 8.051. So doing this, you have that X4 is equal to 0.276. So H4 is equal to HF4 plus X4 HFG4. So HF4 is 121 plus 0.2762433. H4 is equal to 793 kilojoule per kilogram. So as you can see, we have found the values of H1, H2, H3 and H4. So you can say therefore H1 is 1008 kilojoule per kilogram. H2 is 2803 kilojoule per kilogram. And H3 is 1863 kilojoule per kilogram. H4 is what, 793 kilojoule per kilogram. So with that, they asked us to calculate the heat and work transfers, like heat supplied, turbine work, the pump work, and heat rejected. So how do we go about this? Remember that I said heat supplied is given by heat supplied QS. Heat supplied is given by A2 minus H1, which is 2803 minus 1008, which will give us 1795 kilojoule per kilogram. Okay, kilojoule per kilogram. Then the next is the turbine work. First one is the turbine work, or this expansion work. So let's call it the turbine work. Turbine work, which is given by H3 minus H2, which is 1893 minus 2803. Alright, is that the value? Yes, that's the value. Is equal to minus 940 kilojoule per kilogram. Alright, yes. So heat loss at the condenser. So the heat loss, call it heat loss, will still refer to our Q loss, which is 793 minus 1863, which will give me minus 1070 kJ per kilogram. Alright, then we have the compressive work, as the pump work, WP. Okay, yeah, this is WT, you can call this WT, and this is WT, that is pump work or compressive work. Pump work. Alright, is equal to H1 minus H4, which is equal to 1008 minus 793. Okay, which will give us 215 kilojoules per kilogram. Alright, okay, alright. Now we'll go to the next question. Remember, this is the A part of the question, which says we should find the work and heat transfers. So we have gotten the work and heat transfers. Okay, so the next is the thermal efficiency, cycle thermal efficiency. Which is given by none other than network over the heat supplied, as usual. Network over heat supplied. Now our network gives the what change in heat. And remember, for your work to be correct, for your answer to be correct, you have to do one thing. Now let's review our answers. Now, as you can see, we have our heat supplied 1795 and also heat loss, that is minus 1070. So but the magnitude of it is 1070. So the change in heat must equal the change in work. If they are not equal, then you have failed. So they have to be equal to make your process correct. So let's check if ours is equal. So network at the same time called net heat. network, which is Wt minus Wp, must be equal to Qs minus Ql. Alright, now let's see if this is true. Now Wt minus Wp is none other than our turbine work is the magnitude of minus 940 is 940 minus Wp 215. That will give us what? 725 kilojoule per kilogram. Alright, punch that on your calculator. So let's check for the heat supplied minus heat loss. Heat supplied gave us 1795 minus the heat loss, which is 1070. That also gave us 725 kilojoule per kilogram. So same as before. Okay, same as before. So we are right, process is right, answers confirmed. So the next thing is to continue with your thermal efficiency. So thermal efficiency therefore is 725 over heat supplied, which is 1795. I said work ratio is given by network over gross work. Alright, and in this case we are dealing with what an ideal cycle, which is Carnot cycle. So your gross work is equal to what? Your turbine work. Alright, your net gross work. So that has a value which is 940 kilojoule per kilogram. So imputing we have 725 over 940. The work ratio hence is 0.771. okay, this is 0.771. okay, yeah. Alright, the next question is the specific steam consumption. Now I also gave this formula in the other page. The SSC, specific steam consumption, is given by 360, that is an hour in seconds per network. So which will give us none other than 3600 over 725. That will give us a value of 4.97. Alright, 4.97 kilojoules. Don't forget. Okay, no, not kilojoules. Remember, the network is under, so it will have to turn upside down. Okay, so kilogram, remember it's per kilogram, so kilogram will come up, kilogram per kilowatt hour. Alright, kilogram per kilowatt hour. So that is it. So we've solved the question, and the question stated that we should find the heat and work transfers, as we have done, the cycle thermal efficiency, work ratio, and the SSC. So we have done all that. We have our answers right before us. So with this, I've come to the end of today's episode. So I urge you to stay tuned for more videos. Thank you.
It leads to liquor on some ladies. Yeah, we did turn up on a daily. It's how I walk up. Yeah, soft walk.